Everyone, welcome to my YouTube channel. Today I am going to solve the today's LeetCode Daily challenge, rotated digits. So the question is very important because it has been asked in many companies like Facebook, Google, Microsoft, Amazon, Arista Networks. So let's solve this question. Question says that an integer x is good if after rotating each digit individually by 180 degrees, we get a valid number that is different from x. Each digit must be rotated. We cannot choose to leave it alone. The number is valid if each digit remains a digit after rotation. For example, 0, 1 and 8 rotate to themselves, 2 and 5 rotate to each other, and in this case they are rotated in different directions. In other words, 0 or 5 gets mirrored. 9 and 6 rotate to each other and the rest of the number do not rotate to each other number and becomes invalid. The number given an integer n, return the number of good integers in the range 1 to n. So question is simple that we have provided a number, and for every number from 1 to n we have to check whether the number is good or not. So the condition of good that every digit must follow rotation, that 0 can be rotated into 0, 1 into 1, 2 into 5, 3 is not relevant, 4 is not relevant, 5 into 2 and 6, 9, 7 is not relevant, 8 it can be converted into 8 and 6 into 9. So we will check whether only relevant number are present and number cannot be same after rotation. Whole number cannot be same. Okay, so if any number that is different, then we can find our number is good if single number is different, and converting all the numbers should be that particular number. So first is very brute force approach, that we will check all the numbers, all the conditions as given in the question. So let's take the example. It is very simple that from 1 to 10 there are 4 numbers, 2, 5, 6, 9 that are only good number because they are different from their rotation and they only are valid. So let's write the brute force approach. In our brute force approach, we have simple dictionary where a number can be converted. So take one answer equal to 0. Answer is a counter. Then we will write a function for rotation, or just first we are going to check for every number I in range 1 to n plus 1. What we have to check? We have to check whether if is good number n, number I. If the number is good, then what we have to do? We have to update our answer plus equal to 1 and just return answer. The code is that simple, and we have to write function is good. So let's define it, is good, and inside the is good we have to pass one number num, and we have to check whether rotated of num. Let's take this rotated num as rotated. Okay, so rotated is, we will create another function rotated that will rotate the number, and we will check if num is not equal to, we'll check if num is not equal to rotated num, let's take it rotated, then we will return true. Okay, else we will return false. Okay, if the number is not equal to current number, let's write the function rotated. So def rotated. So this is the main thing that we have to do. We have to rotate the digit, rotate the number, rotated. So we will pass one number num, then we have to define what digits are changing. So we will define that d equal to, let's take a dictionary, that 0 can be changed into 0, then 1 can be changed into 1, 2 can be changed into 5, then 6 is not changed, can be changed into 9. After that 8 can be changed into 8, and 9 can be changed into 8 colon 8, then 9 can be changed into 9 colon 6, and the rest of the number cannot be changed in any other number, so that are not relevant for us. Then we have to define one variable that is our rotated number. Okay, so rotated number equal to 0. Initially it is 0, and we have to some base, we need some base value that is rotated for the rotation. Let's base equal to 1. Then for every digit we have to extract the digit, and after that perform the conditions. Then we will find digit by finding the remainder of the number, that digit equal to num remainder with 10. Okay, so that will give us the extracted digit, and then we will reduce the number by 10. That means we will delete the particular digit from the number, and then we will check if digit not in D. If digit is not in D, that means digit is not relevant, then we are going to return nothing. Then we can say that we will return none, and for that none we have to write one condition. Condition is simple, that if rotated num is not none, and the number is not equal to rotated num. Okay, so if these are not invalid, then only we will check, and we will update our rotated number with plus equal to d of digit, that will be rotated digit, and multiply with base, and we will update our base, multiply with 10. So our base would be updated, and finally we are going to return rotated num. Okay, so that is the very brute force simple approach. As the question says, we have done. Let's try to run this. Here it should be divided by equal to. Okay, now this is accepted. Try to submit this. Yeah, this is very brute force approach. Now we are going to optimize this approach. For this we are writing another code. Now clear this code. So we will create two different tuples. One is for invalid, and inside invalid we will put the numbers that are not valid. So 3 is not valid, 4 is not valid, and 7 is not valid. Then 7. Okay, so these numbers are not valid. Then another number that can be changed into some another number, so that numbers we will take. So in another set we will take 2 and 5 and 6. So 2 can be changed into 5 and 6 can be changed into 9. So these two sets we have taken. One set is for the checking the number is invalid or not, and another set is for change. So we will we know that set operation are very fast, so we have created two set. Then we have one variable count, then for num in range 1 to n plus 1, 1 to n plus 1. Every time what we have to do, we have convert the number into string. First we will convert the number into string. After that we will create one variable is valid one boolean variable is valid equal to false, is valid equal to true. Let's suppose it is valid, and then initially we will take the number is good equal to false. After that we will check for every character in our string. For char in s is actually a number converted, that has been converted into string format. Then we will check if character is invalid. Okay, if it is invalid set, then what would be our valid equal to false. Okay, that is particular condition that we have to check, that if the character inside invalid, then we will take our is valid equal to false. At that time we will break our loop. Okay, then we will check another condition if it is good. For that, if character in change, then we will mark our is good equal to true. And if is valid, we will check if is valid and is good is underscore valid and is good. If both conditions are true, then we will update our count plus equal to 1, and after that we have to return count. Now try to run this. Yeah, it is accepted. Try to submit that. This function is very this code is very fast. I think something is wrong. I think we should move it out of the loop. Okay, after that we will check this condition. For every character in S, here it should be. Now try to submit that. Again, so the condition should be out of this loop. Now try to run this and submit again. Yeah, now it is accepted. So after completion of this complete number, we will check the conditions. Okay, so another approach is a very optimized approach. So the last approach is digit TP approach. So that would be the most optimized, as the complexity would be big O of digit. So in the last approach that we have shared, the time complexity is big O of n log n, and space complexity of big O of 1. That we haven't used any linear space. So for digit DP, the condition is that we have to build digit by digit, build the numbers digit by digit, and we have to track if it is still valid or not, and at least one of changing digit 2, 5, 6 or 9, and 9 are present. So the key idea for number is good if no invalid digit 3, 4, 7, and the condition at least one changing digits. Okay, so again we have to start our code. S equal to str of n, we will convert number into a string. After that we will find the length equal to ln of s, and then for valid same we will have a set 0, 1 and 8. These numbers are valid and they are same of itself. Okay, and then valid change, we have another set valid change. So the numbers that are changed into another number, that are 2, 5, 6, 9, because 2 can be converted into 5 and 5 can be in 2 and 6 into 9 and 9 into 6. Then we, for our space optimization, we have autonomous LRU cache memory. that I will call here cache pass with none. Then we will write our dp function. So for our dp function we have three parameters. One is index, okay, idx, and another is type, and the last is has changed. So first parameter index is for current digit position, and the second function type is are we restricted by original number n, and last is has changed. Has changed is did we use any number 2, 5, 6, 9 that can be changed into another number. So we have three parameters strict, and we will check if our index equal to length that we have reached the end, and then we will return 1. And if has changed, if our number has been changed, okay, else we will return 0. After reaching the last length we will check the number is changed or not, and if the number is changed then we will return 1, otherwise we will return 0. Then we will initialize our limit would be int of s of index idx if tied. What is the type? Type means are we restricted by original number n, okay. Then if type, else we will update our limit as 9, that would be the maximum number. Then total equal to 0. For digit in range, limit plus 1. Then we will check if digit in set 3, 4 and 7. Then we will continue because these number we don't have to take in, so we will continue the process. After that we will create another variable, new type equal to type, and digit equal to limit. Okay, then we will have one another variable, new change equal to has changed, or digit invalid change. Okay, after that we will update our total plus equal to dp. Inside dp we will update our index plus 1, comma, we will pass our new type, then we will pass new change. Okay, after that we will return, our function will return total, and we will finally return dp of 0 is our starting index, and we have to restrict it that we will true, and the number has changed is initially given false. Now try to run this. Something is error, return outside of the function. Okay, so it should be here. Okay, so now it is accepted. So now try to submit that. Yeah, it is 100% optimized. So that is the most optimized code that has time complexity of big of digit. So thank you for watching. It is known as a digit DP approach. Hope you understand this question.